Assalamu alaikum, grade 9s. Today we're going to be doing 9.2 and 9.3 together because they're connected. Basically, they're all about solving inequalities. So in 9.1, you talked about how to represent inequalities, and in these two sections, we're going to actually solve them. In 9.2, we're going to be solving single-step inequalities, and then in 9.3, we're going to move on to multi-step inequalities. Now, one thing you need to understand is that solving inequalities is pretty much the same thing as solving equations, and you follow the same process to do so. So we're going to get started. I'm actually going to skip example A for a sec. We'll come back to it. So we're going to go straight into part B right here. So to solve the inequality, we are going to do it by isolating the variable, which is the same method we used when we were solving equations. So we have x minus 3 is greater than or equal to 2. Now, if you wanted to isolate x, if this greater than or equal to was just a regular equal sign, the first thing you would do would be to add 3 to both sides to isolate for x. These would cancel each other out, and then you would be left with x is greater than or equal to 5. And that's your answer. So it's the same process as solving equations, except instead of an equal sign, you have an inequality. So let's do another example. Here we have negative 5 is greater than x over 3. So if you wanted to isolate for x, what would you do? Well, x is being divided by 3, so the opposite is to multiply by 3. And what you do to one side, you do to the other. So then you get x on the right, and you have the sign here, and negative 5 times 3 is negative 15. And that's your answer. So your answer would be that negative 15 is greater than x, or you can say that x is less than negative 15. They are saying the same thing. So one thing we need to make a note of, so it's here in this box down here, but I actually wrote it over here. So when you are solving inequalities and you are multiplying or dividing by a negative number, and only by negative numbers, which we haven't done yet, you need to flip the inequality, okay? So when you are multiplying or dividing by a negative number to isolate the variable, you must flip the inequality. What do I mean by this? So let's go back to our first example. So our first example here was negative 2x is less than 8. Now it says to solve it using blocks and using a model. We're not going to do that. We're just going to solve it using algebra. So if we wanted to isolate for x here, x is being multiplied by negative 2, so the opposite is to divide by negative 2. And what you do to one side, you do to the other. Now, here you should have a trigger that says, okay, this I divided by negative, that means I need to do something. And that something is you need to flip the inequality. So if it was less than, the way that you flip it is to make it greater than. And then you just continue to solve normally. 8 divided by negative 2 is negative 4. And this would be your answer. So you have to flip the inequality because we divided by a negative number. Okay? Now let's check if this makes sense. So this says that x has to be greater than negative 4. That's what our answer is. So if we have negative 2 times x, in order to make it less than 8, it's saying that x has to be greater than negative 4. Well, if x is 4, let's say, negative 2 times 4 is negative 8, which is less than 8. Now this 4 that we used is greater than negative 4. What if we use something that's less than -4? Like, for example, -7. So -2 times -7 would be +14. And is +14 less than 8? No, it's not. So in order for the statement -2x is less than 8 to be true, x has to be greater than -4. Okay? So you can always go back and check if your answer and if your reasoning makes sense. So this, guys, you need to write this down in your notes. You need to star it. You need to highlight it. It is really, really, really important. And we are definitely going to be testing you on this note to make sure that you guys flip your inequalities and get the correct answer. So it's only when you multiply or divide by a negative number when you're solving for x. That's the only time you flip. Okay, here we didn't flip because we didn't multiply or divide by a negative number. Here we multiplied by 3. Even though -5 is here, we didn't multiply by a negative number. So we did not flip the inequality. Okay, so you need to be careful of that note. So let's do working example 2, where we verify solutions to inequalities. Okay, so the first thing we need to do is define what it means to find a solution of an inequality or to an inequality. Basically, a solution to an inequality is a value or set of values that satisfies an inequality Now, the difference between solving an inequality and solving an equation is that there's not just one, one possible answer. So x is not just one thing. It can contain one value or it can contain many values. So I'm going to say can contain many values. For example, if you say that x is less than 3, there are many options for that, right? Like x can be 2, x can be 0, x can be -5, right? All of those and more satisfy that inequality. So that's something to definitely keep in mind with inequalities. There's not just one number that's your answer. So let's do this question here. So Trevor solved the inequality -2x is greater than or equal to 11. He showed his solution and where he got x is greater than or equal to -5.5 on a number line. So it says verify whether Trevor's solution to the inequality is correct. Verify means to check your answer. Okay, so what we want to do is we want to check if his numbers work. So there's different ways that we can do this. The first is that we can actually solve it ourselves and check if his answer is correct. The second thing is that we can actually plug in numbers to do it. So the first thing I'm going to do is actually do the equation myself and check if it's correct. So -2x is greater than or equal to 11. So if I was solving for x here, the step I would do would be to divide by -2 on both sides. Now right away when I divide by -2, I should think, okay, that's something I need to be aware of because I'm dividing by a negative number, which means I need to flip the inequality. So I'm going to flip right away so I don't forget the inequality and then do the math. 11 divided by -2 is -5.5. Now, is this the answer he got? He put x is greater than or equal to -5.5. And I got x is less than or equal to -5.5. So we got different answers. Who's correct? Well, we can plug in our answers and check. So from what I'm seeing, he probably forgot to flip the inequality. So let's check if his answers are correct. So we're going to plug in numbers. To verify Trevor's answer. Okay, So Trevor said that x has to be greater than or equal to negative 5.5. So let's pick a number that fits that range. I'm gonna choose um, the number positive 1. So let's say if x is positive 1 and I plug it into my original equation. So negative 2x is greater than or equal to 11. And if I plug in positive 1 here, does it satisfy the equation? Well, negative 2 times 1 is negative 2. Is negative 2 greater than or equal to 11? No, it's not. So his answer can't be right. If we plug in numbers to check our answer, to verify our answer, well, we got that x is less than or equal to negative 5.5. So a number that's less than negative 5.5, I would say, is negative 10. So I'm going to say let's make x equal to negative 10. So the equation originally was negative 2x is greater than or equal to 11. So if I plug in my negative 10, does it satisfy the equation? Well, negative 2 times negative 10 is positive 20. Is positive 20 greater than or equal to 11? Yes, it is. So we know that our answer is the correct one and Trevor's was not correct. Okay, working example 3 is about modeling and solving a problem. So this is now using inequalities for word problems. So it says games are on sale for $12.50 including tax. So you don't have to worry about adding, your 7% tax. And then it says Sean has $80. How many games can he buy? So let's first write an inequality to model the problem. So each game costs $12.50 and Sean has $80. So him having $80 means that he can spend $80 or less. He cannot spend more than $80, but he can spend $80 itself, and he can spend less than $80 because that's what he has. So we know whatever he buys has to be less than or equal to $80 because that's what he has. And the games are $12.50 each. So if he buys one game, it's $12.50. If he buys two games, it's $25, and so on. So that means that the games are represented by $12.50x because 12.50 times however many games he buys. So that has to be less than or equal to the $80 that he has. So that's our inequality to model the problem. And now we can solve our inequality. So when you want to isolate for x in this situation, x is being multiplied by 1250. So the opposite operation is to divide by 1250. So divide by 1250, what you do to one side, you do to the other, and these cancel each other out. Now, did we divide by a negative number? No, so we don't need to flip the inequality. So the inequality stays as less than or equal to x is what's remaining here, and then 80 divided by 1250 is 6.4. Now, x is less than or equal to 6.4, but does that answer our question? The question says how many games can he buy? Can he buy 6.4 games? Well, no, because you obviously can't have 0.4 of a game. So we know that he can only buy less than or equal to 6.4 games. So what we can say is the most games he can buy is 6, right? Because if he buys 6 games, he'll still be within his budget. But if he buys 7 games, which is the next number up, he will be over $80, which won't work. And then that's how we justify our answer. So it says to explain the solution in words, this is what you would have to say. Okay, the most games he can buy is 6 because of this answer. X has to be less than or equal to 6.4. All right. So we're going to move right into 9.3, which is solving multi-step inequalities. So again, guys, it's only a couple pages. So it's the same thing as chapter 8, which was solving multi-step equations, but instead of an equal sign, we have an inequality sign. Okay? So the first example says solve x over 4 plus 3 is greater than 8. And then it says use algebra and a number line to show your solution and then verify your solution. So we have to solve it and then we have to put it on a number line, our answer. Okay, so if we were doing SAMDEB, okay, you still have to do opposite operations to solve this. So the first thing we would do is minus 3 from both sides to cancel it out. Then we're left with x over 4 is greater than. Here we have a negative, but are we multiplying or dividing? No, so we do not flip the inequality. 8 minus 3 is 5. And then our next step after addition subtraction is multiplication division. So x is being divided by 4, so the opposite is to multiply by 4. What you do to one side, you do to the other. We're multiplying, but we're multiplying by a positive number, so we keep the inequality the same. And then 5 times 4 is 20. So x is greater than 20. And then the next step that we have to do is put it on a number line. When you're putting it on a number line, you guys, you don't need to start at 0. You don't need to do all that. You literally just need to put your solution. You can put the number before and the number after if you want. But what I'm looking for is that you have the boundary point. So x is greater than. So it's not a filled in circle, it's an open circle, okay? Because it's not equal to. And then is it going to the right or to the left? Well, x is greater than 20, which means it's going to be pointing an arrow to the right. And that's all I'm looking for in a number line, okay? You don't need to have from 0 to 20 written down. You just need to have the boundary point, which is 20. You have to show me if it's an open or closed circle and the direction of the arrow. Those are the 3 things you're going to get marked on. The question says to verify our solution. So we can check. If you guys are comfortable making a chart, you can. Or you can plug it in just like what we did before. So on the left side, we have x over 4 plus 3. And on the right side, we have 8. And then it has to be greater than. So we said that x has to be greater than 20. So let's pick a number greater than 20. I'm going to pick 40. So let's say that x is 40. And then, so I'm going to plug it in. 40 over 4 plus 3. 40 divided by 4 is 10. Plus 3 is 13. Is 13 greater than 8? Yes. So we know that our answer is correct. That's how you verify it. Okay. Here we have another example. This one is like what we did in 8.4, where we have x's on both sides of the equation. So remember, before you do any SAMDEB, what you have to do is move all the x's to one side and then move all the numbers to the other. So I'm going to, the one difference is that you have to be careful in chapter 9, because in chapter 8, it didn't matter. You could move this to the right or this to the left. It doesn't really matter. But with chapter 9, it still doesn't matter. You can do anything that you want. But when you're in your final answer, you have to be careful of how you interpret it. So I'm going to do it the way that might be confusing by moving the negative 3 to the right. So we're going to have the x's on the right. So I'm going to add 3x. And what I do to one side, I do to the other. That cancels it out. So then I have negative 10 is less than or equal to 8x plus 38. Then I'm going to move I'm isolating for x, so minus 38, minus 38. These cancel. Okay. So negative 10 minus 38. So you're getting more negative. You do AO, so you add the opposite. So that would be negative 48 is less than or equal to 8x. And then to isolate for x, you divide by 8, divide by 8. It's positive, so we don't do anything to the sign. We keep it the same. And then negative 48 divided by 8 would be negative 6. Now, this is where it gets a little bit tricky. It's not tricky, but you just have to be careful with it. So this is saying negative 6 is less than or equal to x. Okay? So when you're drawing your number line, okay, I'm going to put negative 6. And then you can put negative 7, negative 5 if you want. Now, what you want to do here is, first of all, is the boundary point closed or open? Well, it's closed because it's equal to, and it's on negative 6. But you have to be careful with your arrows. This is where it can get tricky. So here it's saying that negative 6 is less than or equal to x. The way that you read this is in terms of the negative 6. But your number line is always in the point of view of x. Okay? So you're always wanting to do point of view of x on the number line. So if I rewrote this to be in the point of view of x, I would say that x, if I read it backwards, x has to be greater than or equal to negative 6. And this is what you want to plot on your number line. Okay? So you want to make sure that the arrow represents the point of view of x. So x is greater than or equal to negative 6, which means that the arrow is going to be pointing to the right. And this makes sense because negative 6 is less than or equal to x. And the opposite of that is that x would be then greater than or equal to negative 6. Okay, so you have to know that your number line is always in the point of view of x. You can verify your solution by plugging in numbers. So we said that x has to be greater than or equal to negative 6. I'm going to just make it easy and make x equal to 1. So on the left side, we had negative 3x minus 10. And then here we had 5x plus 38. And a less than or equal to sign in front of them. In between them, sorry. And then if I plug in positive 1 for x, I get negative 3 minus 10, which is negative 13 on the left. And we have to check if it's less than or equal to what would be on the right. So 5 times 1 plus 38. 5 times 1 is 5 plus 38 is 43. So is negative 13 less than or equal to 43? Yes, it is. So that means our answer was done correctly. Okay, I want you guys to pause the video and try this question using method 1, which is use the distributive property. So pause it, come back and check your answer. Okay, so if you solved it using the distributive property, you should have got that negative 2 is less than or equal to x, or x is greater than or equal to negative 2. So if you didn't get that answer, please pause and check the work and make sure that you did it correctly. I'm going to show you another way to solve this type of equation where instead of using the distributive property, we're going to actually divide first. So here we have negative 2x plus 3 is less than or equal to 10x plus 18. So what do I mean by divide first is instead of distributing out this 2, we just want to get rid of it right away by, since negative 2 is being multiplied by what's in the brackets, we're just going to divide by negative 2 to get rid of it. So we're going to cancel it out by dividing by negative 2. And what you do to one side, you do to the other. Now right away, this should trigger a warning for you. We divided by a negative, so right away, just to make sure you don't forget it later, flip your inequality. Okay? So on the left side, we're left with x plus 3. And on the right side, we have a binomial divided by a monomial. And we learned how to do this, right? So we're going to do 10x divided by negative 2 first, which would be negative 5x. And then positive 18 divided by negative 2, which would be negative 9. And now we have a simpler equation that we can solve. We can get all our x's on one side. So I'm going to add 5x, add 5x to cancel that out. And this leaves me with 6x plus 3 is greater than or equal to negative 9. And then I'm going to minus 3 from both sides. 6x is greater than or equal to negative 12 because I did AO here. And then to finish it off, to get x, divide both sides by 6. And then I get x is greater than or equal to negative 2. Now, is that the same answer I got as if I distributed? Yes. Oops. Yes, it is, right? X is greater than or equal to negative 2. X is greater than or equal to negative 2. We're dealing with different numbers here, and we're solving a different equation at the end. But in the end, we get the same answer, okay? So you can choose whichever method you like better and use that method to solve for your answer. All right, our last thing that we're going to do for chapter 9 is a word problem. So here we have it says 2 stores want to hire Sada. Store A, I'm just going to use highlighter. Store A pays a flat rate of $55 per day, plus she'll get 3% of sales. That's her commission. Store B pays a flat rate of $40 per day, plus 5% of sales is her commission. And then it says, how much does Sada need to sell? So how much sales does there have to be in order for store B to be the better offer? Now, what does it mean to be the better offer? Okay, the better offer means that she's making more money. Okay, and then which means that store B money has to be greater than store A. Not greater than or equal to, not less than, it has to be greater than. Okay, so store B has to be greater than store A. So let's plug in our information into this table. You obviously don't have to use a table if you don't want to. This is just there to help you set it up. So it says let S equal the value of Sada's sales for a day. And so that's how much sales she has. That's the variable we're going to use. And it says find S when the pay for store B is greater than the pay for store A. So store A is paying $55 per day, whereas store B pays $40 per day. And in store A, she'll get 3% of sales, whereas store B, she'll get 5% of sales. So the commission that she'll get for store A, you're gonna add 3%, which is 0.03 times the number of sales. That's how much she'll get on top of her pay. And same thing for store B. 5% of sales is 0.05 S. So if you combine them together, the pay for store A would be the $55 per day plus 3% of sales. And for store B, it would be the $40 per day plus the 5% of sales. Now, you have your two inequalities. What are you going to do with them? Well, we want store B to be greater than store A. So I'm going to write that here. So we want store B to be the better option, which means it's going to give you more money. So store B greater than store A. Now the inequality for store B is 40 plus 0.05 S, and we want that to be greater than store A, which is 55 plus 0.03 S. And now you just solve it normally like you've been doing, okay? So you can subtract 55 from both sides to cancel it out here. 40 minus 55 is negative 15. Plus, we still have the 0.05 S is greater than 0.03 S. Now, I'm going to subtract 0.05 S from both sides. Okay. And then you have negative 15 is greater than, and then we have 0.02 S. And then what you have to do now is just isolate for S. Okay? Sorry, this is negative 0.02 S. So to isolate for S, you have to divide by negative 0.02 What you do to one side, you do to the other. These cancel, and right away what you should say is that I divided by a negative, okay? Which means what do I have to do? Flip the inequality, okay? So then you just left with S on the right, and then negative 15 divided by negative 0.02. Well, the negatives cancel each other out. And then 15 divided by 0.02 is 750. So 750 is less than S, which means that S has to be greater than 750. So in order for the sales to, in order for store B to be the better option, she has to make more than $750 in sales. So more than $750 in sales would be how to make store B the better option. All right, guys, and that's it for chapter 9. That's also it for unit 2. So we are done the unit, we are done the chapter, and we are going to be moving into our next unit next week, inshallah. Okay, here's your textbook practice questions. If you have any questions, please message me or Miss Lynn. Assalamu alaikum.